The absence of engine bleed air on reciprocating engine aircraft makes the use of an air cycle air conditioning system impractical. Vapor cycle air conditioning system is used on most non-turbine engine aircraft equipped with air conditioning system. However, it is not a source of pressurizing air, unlike the air cycle system of a turbine engine aircraft. The vapor cycle system only cools the cabin. If such aircraft is pressurized, it uses engine-driven cabin air blower or engine-driven supercharger or exhaust gas-driven turbocharger. The vapor cycle air conditioning system is a closed system, used solely for the transfer of heat from inside the cabin to outside the cabin. The first theory for the vapor cycle air conditioning system is that energy can be neither created nor destroyed. It can only be transformed and moved. During vapor cycle air conditioning, heat energy is moved from the cabin air into a liquid refrigerant. Due to the additional energy, the liquid refrigerant changes into vapor. The vapor refrigerant is compressed and becomes very hot. It is removed from the cabin, where the heat from the hot vapor refrigerant is transferred to the ambient air. This cools and condenses the vapor refrigerant into a liquid. The refrigerant returns to the cabin to repeat the cycle of energy transfer. Heat is an expression of energy. It is measured by the temperature. The higher the temperature, the more energy it contains. Heat always flow from hot to cold. This terms express the relative amount of energy present in two substances, not the absolute amount of heat energy present. Without a difference in energy levels, there is no transfer of heat energy. Adding heat to a substance does not always raise its temperature. When substance changes state, such as when liquid changes into a vapor, heat energy is absorbed. This is called latent heat. When a vapor condenses into liquid, this latent heat is given off. The temperature of the substance remains constant during its change of state. The latent heat is used for the change process. Once the change of state is complete, heat added to the substance raises its temperature. After a substance changes state into a vapor, the rise in temperature of the vapor caused by the addition of still more heat is called superheat. The temperature at which a substance changes from liquid into vapor when heat is added is known as its boiling point. This is the same temperature at which a vapor condenses into a liquid when heat is removed. The boiling point of a substance varies directly with pressure. When pressure on a liquid is decreased, boiling point also decreases. When pressure on a liquid is increased, its boiling point increases. For example, water boils at 212 degrees Fahrenheit at normal atmospheric pressure of 14.7 psi. When pressure on liquid water is increased to 20 psi, it does not boil at 212 degrees Fahrenheit but at 226.4 degrees Fahrenheit. Water can also boil at much lower temperature, simply by reducing the pressure upon it, with only 10 psi of pressure upon liquid water. It boils at 194 degrees Fahrenheit. Vapor pressure is the pressure of the vapor that exists above a liquid that is in an enclosed container at any given temperature. The vapor pressure developed by various substances is unique to each substance. A substance that is volatile develops high vapor pressure at standard day temperature of 59 degrees Fahrenheit. Volatile substances develop high vapor pressure at lower temperature due to its lower boiling point. The boiling point of tetrafluoroethane R134A Refrigerant used for most aircraft vapor cycle is at -15°F. Its vapor pressure at 59°F is about 71 psi. The vapor pressure of any substance varies directly with temperature. Vapor cycle air conditioning is a closed system in which a refrigerant is circulated through tubing and a variety of components. The purpose is to remove heat from the aircraft cabin while circulating. The refrigerant changes state by manipulating the latent heat to do so. Hot air is replaced with cool air in the aircraft cabin. To begin, R-134A is filtered and stored under pressure in a reservoir known as receiver dryer. The refrigerant is in liquid form. It flows from the receiver dryer through tubing to an expansion valve. Inside the valve, a restriction in the form of a small orifice blocks most of the refrigerant. Since it is under pressure, some of the refrigerant is forced through the orifice. It emerges as a spray of tiny droplets in the tubing downstream of the valve. The tubing is coiled into a radiator-type assembly known as an evaporator. A fan is positioned to blow cabin air over the surface of the evaporator. As it does, the heat in the cabin air is absorbed by the refrigerant, which uses it to change state from a liquid to a vapor. So much heat is absorbed that the cabin air blown by the fan across evaporator cools. This is the vapor cycle conditioned air that lowers the temperature in the cabin. The gaseous refrigerant exiting the evaporator is drawn into a compressor. The compressor further increased the gaseous pressure and temperature. The high pressure and high temperature gaseous refrigerant flows through tubing to a condenser. The condenser is like a radiator, comprised of a great length of tubing with fins attached to promote heat transfer. Outside, ambient air is directed over the condenser. The temperature of the refrigerant inside is higher than the ambient air temperature outside, so heat is transferred from the refrigerant to the outside ambient air. The amount of heat given off is enough to cool the refrigerant and to condense it back to a high-pressure liquid. The liquid refrigerant flows through tubing and back into the receiver dryer, completing the vapor cycle. There are two sides to the vapor cycle air conditioning system. One accepts heat and known as the low side. The other gives up heat and is known as the high side. The low and the high refer to the temperature and pressure of the refrigerant. As such, the compressor and the expansion valve are two components that separate the low side from the high side of the vapor cycle.